Environmental evaluation of concrete using fly ash, biochar, and carbon sequestration. Concrete pavements are important, however, roadway systems are responsible for the substantial energy and resource consumption. Road networks in the Philippines play an important role in commerce and social movement of citizens as evidently shown from the various road networks being constructed in different parts of the country. With the increasing effect of climate change, policymakers and engineers are continuously seeking ways to reduce the environmental impacts of road construction. Reducing the greenhouse gas emissions of pavements requires a complete understanding of how it impacts the natural environment. Concrete pavements emit greenhouse gases through its life cycle, from the extraction of raw materials to the construction process, continue to its operation, maintenance and waste management, and recycling. Use of environmentally friendly materials and technologies in road pavements have reached high relevance mainly due to the increasing public consciousness addressed to environmental preservation. However, replacement of materials in the perspective of sustainability remains a question that needs to be addressed. Along with the development and urbanizations happening in every part of the world, environmental degradation is becoming an alarming issue. And with the continuous growing population and uncontrolled extraction of raw materials for production for the benefits of humankind, environment is severely affected. Fly ash is generally considered as a waste material that is produced as a byproduct of coal combustion process. Biochar is a special type of charcoal that is produced by pyrolysis. This charring process traps the carbon dioxide a plant absorbs from the atmosphere during its lifetime, keeping it from being released into the atmosphere. And one of the emerging possible solutions is the sequestration of carbon, a cementitious material that is the process of capturing and storing atmospheric carbon dioxide. Objectives of this study includes quantifying greenhouse gas from the mixtures used and comparing mixtures with and without the process of carbon sequestration using fly ash and biochar, and to recommend optimum mixture for sustainable design. And for the process, the following were used in the analysis using life cycle assessment, considering cradle to gate in determining the amount of carbon footprint resulted in the construction of concrete pavement. Life cycle assessment considering infrastructure is a method that considers the effect on the environment of different materials being used in construction, as described in the international standard ISO 14040 and 14044. For research design, conventional mix, 3 manufacturers of concrete mix, and 1 mix with biochar were considered. Materials, construction, and use were applied in the process of LCA to determine the greenhouse gas emission to come up with the optimum design. After the simulation using CIMAPRO, it was proven that the conventional concrete used by DPWH, with and without injecting carbon dioxide, has the largest amount of carbon dioxide emission. Company B produced the least amount of carbon dioxide emission with 23% fly ash and even decreased it for about 7.28% when there is an intrusion of carbon dioxide for about 10 to 30%. Results of this study provided another proof on the effectiveness of fly ash that can lower carbon dioxide emission, and with the use of biochar that can keep carbon out of the atmosphere through the application of carbon sequestration, which can speed up carbonation process. Knowledge dissemination will help people to become aware on the development of sustainable materials and how it will help in our environment.